G'day guys, Rufus here from Rufus's Rocket Ship. I thought we'd do something a little bit different today, just because I felt a bit sciencey, and I thought, why not? It's always good to get something different down. Right, so I'm going to explain to you how lightning works, how it actually, generally, most times strikes upwards, not downwards. But equally downwards as much as upwards. It's all to do with interpretation. It's all to do with severity of storm and all that stuff. So let's get started. We're going to chuck in some clouds up here. Oh, you probably can't see that, so we'll chuck in some clouds up here. So this is our thunderstorm cloud. Now these thunderstorm clouds can be anywhere from a few hundred meters in height to kilometers high. Like clouds of the generally generated storms are huge. Their size is just massive. And what begins the process of a thunderstorm or a thunder and lightning storm is that you have basically what we have inside the cloud. Where's my mouse? There it is. Is we have little, I'm not sure if you can see those, we'll just splash them around, ice crystals, particles of ice that are being tossed around with the high winds that are in there, and they're colliding and they're creating friction, and with that friction they're creating energy. Now because the Earth has a massive amount of positive and negative energy about it, and a lot of that positive energy is at the top, because the negative energy, when you get that sorry, when you get that mass amount of energy in the cloud, you start to create these opposing forces. So the negative energy in the Earth gets slightly pushed down, and we lose a balance. So it's no longer this balance of negative and positive energy in the ground. And all the positive energy, all the positive electrons get pushed up to the surface. So if you've ever been sort of standing somewhere, or when you rub a balloon on your head and your hair stand up on end, and you sort of, even if you have it away from your head, not touching your hair, you can sort of almost feel like there's a connection. That's that positive energy coming from your body. You've caused a section of your skin or your body to become positively charged, in a sense, by increasing that electrical charge in that area. So the same things happen with the cloud. So you've got all these particles flying around. Now all the negative energy is getting pushed to the bottom of this cloud, and all the positive energy is going to the top. And because it's happening on such a massive scale, and you have all this negative energy, that's then causing the negative energy in the ground to push down, and the positive energy to rise up, because opposites attract. So all of a sudden you've got these positives down here. You can't really see my cursor that well, so that's frustrating. So all of a sudden you've got is this positive energy down here, and the negative energy up here, which wants to connect. Now, normally, like the common conception is that it just shoots down all that energy and connects. Not the case. So what we have is we'll have a tree. We'll just do that as a tree. It's a really bad tree. Don't don't stress me out on my tree, man. It's my cool tree. Chuck a house down here, and we'll chuck just a person. All right. So we'll imagine these objects. It's a really big person, but anyway, in comparison to the house, it is. So we'll chuck these objects down here, and imagine these objects are in a field by themselves. So what happens in the sky? We've got hydrogen particles. We'll go with hydrogen particles in and all around. We'll just use these particles as an example, and we'll use the stereotypical model of an atom, which is your nuclei or nucleus, and your positively charged electron, negatively charged electron orbiting around. Now, what happens here, which is really interesting, so this is our negatively charged electron and our positively charged nucleus, nucleus. Sorry. So what happens in this atom? And I know that's not an accurate representation of a hydrogen atom, but it's for example purposes. Now what happens, you've got this positive energy down here on the ground, you've got this negative energy up the top, and you've got these two forces that are going to be attracted to those two different energies. So the negative energy goes down, and the positive energy goes up, and it literally rips apart that atom. It rips that atom apart. Now, not to be mistaken for splitting an atom, because if it splits the atom you just have explosions everywhere. No, it just rips the bonds of that atom apart. So all of a sudden you've got those protons and neutrons that are positively charged going up, and the electrons which are negatively charged going down. And this process is called ionization. Now the way this happens is it'll happen in a section of about 50 yards, about 100 meters, somewhere around those. So it'll happen to a section of these hydrogen atoms. So all of a sudden, all of that area has just been ripped apart. You've got all this negative charge, which is sort of stagnant in that area. So you've got all this negative charge, right? And all of this negative charge down here on the bottom of the cloud is pouring into this section here. And all the positive charge that has been ripped apart is pouring out of that section and going up into the top of the cloud. Now, once that happens, and this all happens in the minuteness of seconds, it happens to another section. So once again, you get all of that negative energy, which just gets poured in and pulled down from the cloud into that section, and all the positive energy gets sucked out. And what's happening on the ground at this stage is you have, because of all this positive energy wanting to go up and be attracted to the negative energy, we have what's called streamers. So this process that happens down here, and the way it happens, it can happen off in different sections like that, and it can split, and it literally looks like a lightning strike itself. And if you were to capture it in high definition slow-mo, you would actually be able to see that light process happening, of that ionization of those atoms. So that's happening and going off in different sections. And at the same time, you have, coming out of, say, the top of your head, a streamer. A streamer of positive energy that's being drawn up and pulled up to try and connect with one of these STEPS leaders. Now, it generally comes out of pointy objects. So the point or top of something. It can even come out of just the ground. Like there is some amazing photos around of just how that lightning comes out. Although those streamers come out of the ground or come out of the top of a light pole, or even out of the top of a tree. Now the interesting thing is it's being pulled towards, they're trying to get this connection happening. Now let's say that this connection is made with this streamer here. A streamer that is low to the ground. Alright, so all of a sudden you get your connection. Your connection's made. And this first section here, what does it do? It dumps all of that negative charge. Dumps it straight down into the ground and earths. And then the next section, so after that section's done, the next section dumps. Then the next section dumps, and the next section dumps, the next section, and so on, all the way up. So the lightning, and we see this strike first, so we see this part first. So you've actually got the light, the visible light from the lightning strike, going upwards in a strike. Now this is not rare, but it's not a regular occurrence. And it does happen a lot because there is not much in the way of positive charge there is more positive charge in some areas than there are negative charge in some of the clouds. So obviously if the cloud has a stronger negative charge, it's going to be sending out those feelers a lot quicker. And generally this is the model for a lightning strike. But if we get to the stage where we've got a streamer which comes up so far that it only has time to sort of, say, ionized 1 or 2 sections, then at this point where it connects, it dumps that energy, the light goes up there, and also you've got that connect that comes down here. So it would appear as though the lightning's striking down. So from this point here on our first lightning strike, it strikes down, but it also strikes up. So that is the point of where the electricity happens. So you get some people say, oh no, I've seen it in slow-mo, I swear it strikes down, or I swear it strikes up. That's because you get these two different styles of I suppose, lightning strike in a cloud-to-ground scenario. But, I mean, it happens so fast. You have to realize all of this happens so fast in the blink of an eye. I mean, you're trying to observe electricity, observe the speed of light. It's virtually impossible. But in high-def slow-mo cameras, you can actually see it. Excuse me. So yeah, that is how lightning works in that sense. If you have any questions about that, feel free to post a comment. I'll answer it to the best of my ability. Additionally, thunder. Now, thunder is basically that lightning that happens is so intense and so hot that it superheats the particles and it pushes away all the other cold particles, and there's a massive expansion. And it's basically so fast and so hot that it rips through those particles, and that is what we hear when we hear thunder. We hear that ripping through, and obviously because sound travels at a pokey, I think it's 380 or something meters a second, and light travels at 2 million something or other, or a phenomenal amount of meters a second. So the difference is quite large. So that's why when you see a lightning strike, you see it before you hear it, because obviously the light reaches you before the sound does, and that's why it's always a good way to, if you see a lightning strike, you can count, and you sort of go 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, strike, divide that by 3, and you can figure out generally how far away. So I think it's about 5 seconds is about a mile, which is really cool. But yeah, so that's how a lightning strike works, and generally lightning strikes upwards, and it is just an interesting and fun phenomenon. I hope you understood the video. I hope you enjoyed it. I love science. I love talking about science, and yeah, well, I'll see you guys in the next video. Thanks for watching.